Dear students, in this short video, we shall be discussing about diffraction grating. In the previous video, you have learned about the diffraction due to N slits and this was the intensity pattern. You have also learned that between any two principal maximas, there are N minus 1 minimas, where N is the number of slits in a multi-slit arrangement, right? So this is the principal maxima, this is the principal maxima, this is the principal maxima. These are the secondary maximas, and all of these are the minimas. So what we have learned that between any two principal maximas, there are n minus 1 minimas, and n is the number of slits. Now an actual realization of n slit arrangement in case of diffraction pattern is given by diffraction grating. Suppose you have a plain glass plate, right? And by means of a fine diamond pointer, you draw some rulings over it, right? See, what is your common experience? If you scratch glass somewhere, what happens? That portion turns out to be opaque. So once you draw rulings, lines on this plain glass plate with the help of a fine diamond pointer, what do you get? You get an alternate arrangement of a transparency and an opacity. So you have a transparency and an opacity, Suppose the width of each transparency is A and the width of each opacity is B, right? It is much similar to this arrangement. If the width of slit was E, you can treat it like transparency, and the distance between the two slits was D. This D you can treat much like opacity, and this E plus D is similar to A plus B, and this A plus B or E plus D is called grating element. The condition for maxima is that A plus B sine theta is equal to n lambda, where theta is the angle through which the rays of light or the waves of light have bent on account of diffraction, right? Now, if n is the number of lines per inch of the diffraction grating, then you can say that this A plus B is 1 by n. 1 means 1 inch. And if you want to substitute this inch for centimeter, we know that 1 inch is equal to 2.54 centimeter by n. Therefore, number of lines per unit inch or per centimeter of a diffraction grating is given by this expression, right? So diffraction grating is a practical realization of n slit arrangement. It is used to study the spectra of light sources, and another important application is that it is also used to determine the wavelength of light source, the light source that illuminates all these slits. So that's all about diffraction grating.